The waste segregation using embedded systems.
This is the video demonstration of the basic construction and working of the waste segregator. It is a novel concept for segregation in urban houses to reduce the existing pressure on waste management in municipalities. The main components used in the segregator are the conveyor system, inductive sensing module, capacitive sensing module, and DC motors. The segregator employs MSP430 low power microcontroller for its operation.
We now move on to the construction of the segregator. The conveyor system. It consists of pulleys with a continuous loop of material and it rotates at about 10 rpm speed. In this system, one of the pulleys are barred up and the material moves forward on it. It generally rotates irrespective of the microcontroller. We have 4 provisions for the sensor. One for metal, second for polyethylene terephthalate plastic, the third for polypropylene plastic, and the last one for future use.
Now we move on to the sensing of metals. The metals are detected using the inductive proximity sensor.
There are 2 capacitive sensors to detect the different types of plastics like polyethylene terephthalate and polypropylene.
The robotic arm is used to block the waste once after detection by the sensors. The robotic arm movement is controlled by the DC servo motors.
The following section gives the overview of the TI components used in this system.
There are several TIICs used to implement this system. There is an MSP430 G2553 low-cost, ultra-low-power mode microcontroller used to segregate the wastes. This is the launchpad of MSP430, and there are 2 L293D motor drivers used to drive the inductive loads like relays.
Here is the structure of the segregator. Metallic detection using inductive proximity sensor. As we can see, once the metal moves towards the sensor head, the amplitude of the oscillator increases. Hence, the robotic arm blocks the waste.
Plastic detection using capacitive proximity sensor. There are 7 grades of thermoplastics which can be recycled. Here in this system we differentiate the grade 1 and grade 5 plastics.
The figure shows the capacitive sensor and its internal circuit. The first stage is the oscillator, the second is the demodulator, third is the trigger stage, followed by the output stage.
Each material has a dielectric constant as shown in the figure. For each grade of plastic, the analog output voltage varies with the sensing distance.
This is the grade 1 polyethylene terephthalate plastic. When it is placed near the sensor head, the analog output voltage is 3.83.
When the grade 5 polypropylene plastic is placed near the sensor head, the analog output voltage is 4.33. Thus, the sensor is able to detect the different types of plastics. Thank you for watching this video.